What do particles really look like? Where do their properties come from? What is a force actually doing behind the scenes? In the energy filament theory, the answer starts from a single picture. The universe is not empty space. It is an energy sea that can be pulled tight and wrinkled. Particles are tiny filament loops that this sea manages to wind up and keep alive. Most attempts actually fail. The sea keeps trying to curl filaments into closed rings, but almost all of them are half-baked structures that fall apart in an instant. They give a tiny kick of noise to the background and, while they exist, add a little average pull that can collectively play the role we now blame on dark matter. Over cosmic time, the sea has run an absurd number of tries. It is like a student doing trillions upon trillions of practice problems. Only a few loop designs turned out to be self-consistent enough to survive for long. Those rare, low-cost patterns are what we now call electrons, neutrinos, quarks, and the other familiar standard particles. The shared feature is that they are rings, not spheres. A solid ball leaves energy trapped with no easy route to move, while a ring lets energy circulate along a closed track. Only in that circulation can the loop shrug off disturbances and stay coherent. Once you see the loop, the usual properties stop looking like magic labels. Mass is what you feel when you try to shove that loop through the sea. To lift a bump on a soft sheet, you must drag some of the sheets along. In the same way, a stable filament ring sits inside a region of tightened sea. Pushing the particle means pulling that tightened patch with it. The heavier it feels, the larger and stiffer that patch is. Charge comes from how the loop tugs on the sea inside and outside itself. An electron has a structure where the inner side of the ring is pulled tighter and the outer side looser. The overall pattern is pulling the sea inward. That inward gathering is what we call negative charging. A positron has the opposite layout, tighter outside and looser inside. It looks to the sea like something that pushes texture outward and shows up to us as positive charges. An electric field is just the set of straight, directional wrinkles that these inward or outward tugs leave in the surrounding sea. It is like the creases left in a sofa cushion that has been sat on. Around a negative charge, the straight textures lean inward. Around a positive charge, they lean outward. When two charged particles approach, these wrinkles decide whether they help or fight each other. If two sets of straight textures point the same way and crash, the sea between them cannot relax. It kicks the structures apart, and we call that like charged repulsion. If one texture set is trying to pull in while the other is pushing out, the patterns can plug into each other more smoothly. The sea flows more easily between them, and we see opposite charges attracting. Fields and forces in general are just the sea's slopes. Whenever the sea has a gradient in tightness, with one region pulled harder than another, there is a cheapest direction to slide towards. We draw that as a gravitational field. Objects are not yanked by an invisible hand. They are following the path where dragging their surrounding patches of sea costs the least. When the sea has a gradient from scrambled textures into aligned straight textures, we call that an electromagnetic field. Charged particles drift in the direction that makes the straight wrinkles most regular. Again, they simply follow the easiest pattern the media offers. Gravity and electromagnetism look different in formulas, but in this picture both are the same story. The energy sea always prefers the least effort flow, and matter is carried along those favored flows. Our instruments then translate that into forces. One more ingredient ties the picture together, the internal swirl we kept calling spin. Inside the loop, the energy does not sit still. It runs around the ring like a hula hoop that cannot stop spinning. If the circulation stopped, the loop would lose its support and collapse. This circulating flow cuts spiral textures into the sea, called spinning textures. Those spirals act like latch points. Only at certain angles and rhythms can one spiral pattern lock onto another. Electron orbits around a nucleus come in discrete layers. Atomic sizes jump between specific values. Molecular bonds lock in fixed angles and lengths. From electron shells to nuclear shapes to molecular skeletons. Everything that looks quantized can be seen as structures snapping onto the same family of spiral latches. Put all of this together and the end of the story is simple. Shapes, properties, fields and forces are not four unrelated sets of definitions on a chalkboard. They are four faces of the same thing, an energy sea and its filament loops obeying one rule over and over again. Every pattern that survives is a pattern that found a way to flow and hold with the least possible effort. Tap follow, share it on New Physics, Clear Universe.